My name is André. You can also call me Andre. I'm from Brazil, but I'm currently located in Montreal. I'm a backend engineer, mostly Java. It's my experience. I'm also a Confluent certified Kafka developer, which is exactly what we're going to talk about today. So we have been using Kafka in different projects for the last 5 years, give or take. And different use cases. Some are near real time, some are not. Some we can't afford to lose a single message. Others we don't care so much. So there are a bunch of situations that are running for those past 5 years. I can't talk about them because honestly we don't have time. So I've chosen the situations that I think apply more in general that we can discuss. Or maybe a situation that's a bit more niche, but there is one technique or two that can still be used like in general, okay? So we are going to start first talking about creating topics, because that's usually where we start. We have to create a topic. Then we're going to discuss producer performance tuning, then how to handle producer failures, like in general. And we'll do the same for consumers. So we talk about consumer performance tuning first, and then handling consumer failures, okay? So creating topics. The biggest thing that I see in a lot of projects is topics that have too many partitions, right? So you might have heard before that on Kafka, the more partitions you have on a topic, the better throughput you get. That is true to some extent. It gets to a point where you get diminishing returns. And if you keep adding more partitions than you actually need, you're going to actually harm the performance. So there are different reasons why that happens. But the most important ones is, let's first think about the perspective from the producer side, right? The producer has to send a fixed amount of data, right? If we increase the amount of partitions, the producer, what it does is, internally it batches the messages that you need to send, if in case the producer is busy. And when there is room to send another batch, it will send to the broker that owns that partition, right? So if you have too many partitions, you have too many requests, and you increase the amount of round trips between the producer and the brokers, and you also get smaller batch sizes, which means that your throughput is going to be lower as well. So you harm the producer performance kind of twice, right? The second thing is having too many partitions impacts data replication on the Kafka cluster. It slows it down, and that also increases end-to-end latency. So why is that? The first thing is the brokers, just a minority, they have a single thread that takes care of replication for all the topics and partitions that that broker owns. So if you have too many partitions, there is more work for that single thread to take care of. It's going to have a backlog, and that's going to slow down the replication. And the way this impacts the consumers, the end-to-end latency, it's because a consumer, it's only going to see a message once it has been fully replicated across all the brokers that have that partition, that have a copy of that data, right? So if you're familiar with the producer ACKs configuration, changing the ACKs configuration doesn't change this behavior. Like you can set ACKs to none. Still, the consumers still are only going to see messages once they have been replicated across all the brokers. Okay. Finally, the thing you have to be careful about is you cannot lower the amount of partitions. So if you create a topic that has many partitions, the only thing you can do if you want to reduce, you have to create another topic that has less partitions, and then you have to change everyone, the producers and consumers, to use the new topic, right? Now, let's say that, okay, I'm going to create a topic. How do I choose the amount of partitions, right? What I see often is either people guess or they just copy based on another topic, right? So there is a simple process that you can follow to define the amount of partitions. So when you create a topic, you start with a single partition. Then you measure the throughput that you were able to get with one partition, both on the producer side and the consumer side, right? And then you take whichever one is slowest, because on a stream processing application, you can only be as fast as your slowest component, and you extrapolate, right? So let me give you one example, right? Let's say we have an SLA, we have to get a throughput of 100 messages per second. The producer, we create a topic, single partition, we test the producer is able to do 20 messages per second. But the consumer, it's a bit slower, it only gets 10. So we take the worst value, the messages per second, and then we just scale linearly, right? So we need 100 messages. The consumer is able to do 10 with one partition, so therefore we need 10 partitions, okay? If you're doing this, there are a few tricks that you can use to measure the performance in the sense that ideally you would do this once you have the entire producer code and the consumer code available, so you can measure the actual behavior right of the two clients. But there are some shortcuts. So for instance, there was one project where we had the consumer, it would call an API to enrich data, right? That's a common use case. And the API wasn't available yet. But we had an SLA for the API. Let's say, it would take like 50 milliseconds per call, per request. So instead of waiting for the API to become available, we just created like a dummy API that would sleep for 50 milliseconds. And with that, we were able to measure the consumer. So you can use some techniques like this to get an idea of how many partitions you need beforehand, okay? So now next we're going to talk about the producer performance. So producer performance, let's start with the good practices. The major one, if you need to take one thing out of producer performance, is enable compression. I still see a lot of projects that don't have compression enabled. It's trivial to enable. You just need to say compression type, and then you choose the algorithm that's supposed to be used for compression. And basically, you always choose the STD. Today, there is no reason to use the other ones. The STD is lightweight and efficient, so it's the one that you want to use pretty much all the time. And the reason compression is efficient, it's because it is done on the producer side, and then the compression only happens on the consumer side, right? So the producer is going to take a batch of messages, it's going to send to the broker compressed, the broker will take that batch and store on disk compressed, and on the other end, when the consumer asks for messages, the broker is going to read from disk still compressed, it's not going to decompress, it's going to send to the consumer as is. So throughout the entire data pipeline, you have compression from end to end, right? So it's very efficient, right? The next good practice that I suggest, it's to move computation away from producer threads. So what happens if you're using the official Java client, right? When you send a message to a producer, you can provide a callback, and then actually sending the messages to the brokers is always asynchronous. And if you pass a callback, the producer is going to let you know, if it was able to send a message successfully or not, right? Then the thing is, that callback, it's going to run on the producer IO thread. So if you do any expensive work inside that callback, you're going to block the producer IO thread, and you're going to harm the producer performance, right? Now, when you're using callbacks, that's easily to spot, when you're doing expensive work on the callback. But when you use higher level clients, like for instance, Spring Kafka, or using like a reactive Kafka client, it becomes harder to spot these things. Like if you take Spring Kafka, for instance, instead of using callbacks, it uses futures, right? Which is the Java implementation of promises. If you take that future that came from the client, any operation that you chain on top of that future, now it's going to run on producer threads. And the same thing is going to happen if you use a reactive client, right? So what we do on pretty much every project is, as soon as we have the future or the flux, the mono, doesn't matter, we moved computation away to a different thread pool, right? There's some overhead you get because of the context switch, but it's minor compared to the risk of, I don't know, 5 years from now, someone doesn't know that, the future is, any operation you change is going to run inside the produce IO thread, and then the harm performance is not something that's easy to spot in a PR review. So we do this pretty much for every producer. Now, another recommendation is to consider refactoring your code to call the producer as frequently as possible. So I have an example on the next slide, a couple situations. So on the left, we have a pretty simple situation. We have a bunch of messages. For each message, we're going to call an API, do some expensive transformation. And then once we have the enriched message, we call the producer to send it to Kafka, right? So this is good because there's low latency. As soon as you have the data you're supposed to send, you're sending it. But the problem is, like I mentioned before, the producer, it's asynchronous. And if it's busy, it will buffer your messages internally, right? And then once there is room to send data, it will take an entire batch of data and send at once, right? So that's efficient. It minimizes round trips between the producer and the broker. But in this case, on the message, on the image we have on the left, right? If we go and send a single message to the producer, right? And then before we send the next one, we do some expensive work. The chances are that by the time you're done doing the expensive transformation, the producer will have sent this message already, right? So you're going to have batches that have a single message. That's not very efficient. So what you can consider is you do what's on the right image, right? So instead of doing the transformation one message at a time, consider doing it at once, and then you just call the producer on a tight loop, right? So that's going to optimize the throughput. The problem is, of course, you're going to increase latency. So because the very first message, it takes a while for it to be sent because you have to transform all the other ones. So what we usually do on projects is we introduce like micro batching internally. So for instance, let's say we have 10,000 messages that we want to send. And if we did that, latency would be too high, right? So maybe we define an internal micro batch of 500 messages. So we would take these 500 messages, chunks of 500 messages, and for each of them, we would do the transformation, and then we call the producer on tight loop for those 500 messages, right? So we can have an internal batching parameter to choose better the trade-off between having higher throughput, but while also not having high latency, okay? So that's the final recommendation I have in terms of performance, right? So talking about failures on the producers. First, I actually have a story that happened on a project. So when an unstable fire and forget producers impacts the critical path. So what happened is we had a fire and forget producer. So if the messages failed, we didn't care as much. We were okay with losing some messages. It became unstable because one of the partitions it was trying to write to, it was unavailable because it was under-replicated. So it was a broker issue. Now, because it's a fire and forget producer, there shouldn't be any issue, right? The critical path of the application, it shouldn't be impacted at all. But what happened is the entire application eventually began to slow down a lot. So why was that happening, right? So the problem is when the fire and forget producer failed to send the messages to the broker, it would start doing retries. And by default, it would retry each batch for up to 2 minutes. And while that was happening, when the application called the fire and forget producer to send more data, it would start to buffer the data internally on the buffer, right? Now, that kept happening until the buffer became full, because there's a limit to the buffer size. And once that happens, the producer becomes synchronous. If you call producer.send, it will block. And by default, it will block for 1 minute. So only after 1 minute, the application would get a failure that it could handle somehow. But then at that point, we were already impacting the critical path, right? Because the producer was not asynchronous anymore. So there are a couple of things you can do in a situation like this. You could actually make the producer fire and forget from a configuration standpoint. There's a configuration called ACKs that I mentioned briefly before. You use it to let the broker know how long should the producer wait for replication. Not how long, how many replicas should be in sync, right? So the default configuration is the producer is going to send a batch to the broker. The broker is going to wait for all replicas to acknowledge that they have received that batch. And only then the broker is going to send a response to the producer to say, hey, this was successful, right? If you have a find forget producer, you can change the AC case to none. And when you do that, as soon as the producer sends a request, it will get control back, and you can send the next one. So under this situation, it's extremely unlikely that you're going to get a full buffer because the producer doesn't wait for requests, right? Now, in this particular situation, we couldn't use the set AC case to none because the problem we have with that is if the producer fails, the request fails, you won't know. You won't even be able to log a failure, basically. And for this specific use case that we had, while we were okay with losing some messages, we do wanted to know when that happens, right? So we can understand, if it's happening too much, send alerts and so on, right? So the second thing you can do, which I'm just going to briefly mention because it's out of scope for Kafka, you can use the bulkhead pattern to isolate the failures. So basically what would happen in a situation, if you did that, eventually, if the buffer became full, the bulkhead pattern would take care of making sure that if you try to send messages to a producer that's completely busy, it would just discard the messages. That's what you have. Great. Now, some other things that you need to keep in mind for producer failures. I mentioned how retries can cause the producer to become busy and the buffer to become full, but you can easily get the same situation with timeouts. The default timeouts that the producers have, I find them too high for most use cases. So you might want to consider changing a few of them. So I mentioned a few configurations here. The first one is the request timeout. This is the time, how much time the producer is going to wait for a response for a single request. For instance, it sends a batch of data to the broker, right? The default value for this one, it's 30 seconds, which I think it's too high, at least for the project we have used so far. So we usually lower this one. Lowering this, though, it's something that you have to be careful because if you lower this by too much, there's a risk you're going to introduce duplicate messages on the broker. For a few projects we have, this is okay, so we lower it anyway. But also, this configuration, it depends a bit on a configuration that exists on the broker side, so on the server. So I'm not going to go into specifics because it's a bit too much. But for any of the configurations that I mentioned in this presentation, I recommend you go to the producer of the consumer configuration reference. You can just search for that, and you're going to see a page from Confluent that's going to explain each of these configurations. They go into enough details, not too much, and they explain it really well. So if you check the request timeout MS on the producer configuration reference, it explains what care you should take when changing this. Now, the next timeout is the delivery timeout. So this is basically an SLA between your application and the producer. When you call producer.send or your framework calls producer.send, this is going to be how long the producer has to give you back a response. Either the message was sent successfully or it failed, right? So the default value for this one, it's 2 minutes, which I also find too high. So we usually lower this one as well. But you have to be careful because this is taking into consideration retries. So if you lower this, you're also lowering the amount of retries that Kafka is going to do, right? So on Kafka, the producer, the usual recommendation is you don't change the amount of attempts the producer does. Instead, you change this one. So basically, retries on Kafka, the recommended approach is to retry based on time. So for how long are you willing to wait for the message to be sent, instead of how many attempts should the producer do to send the message. That's usually easier to reason about SLAs if you do a configuration that's time-based instead of the number of attempts to send the message. Now, the final one that I recommend lowering, this is not technically a timeout, but it's related to these two. It's the max block MS. This is the configuration that tells how long the producer is going to block if the internal buffer becomes full. So it's the situation that I mentioned before that happened with the fire and forget producer. So the default value for this one, it's 1 minute. So if the buffer becomes full, the producer is going to block. It will become synchronous. And if the situation doesn't fix itself, you're going to get an exception only after 1 minute. So this is also something that you might want to consider lowering in case the buffer becomes full. Now, the next thing is you have to keep an eye out for. There are situations other than just the buffer becoming full that we make the producer fail synchronously, right? So if you get serialization issues, authorization issues, authentication issues, if you're using schema registry and the Avro serializer can talk to the schema registry, these are all going to become exceptions if you're using the Java client that will be thrown synchronously. So to make sure, you have to make sure that you catch those and you handle those the way you're supposed to handle based on your requirements. And what we usually do for most projects is we have a simple facade in front of the producer, the client, and we catch the exceptions. And let's say we're using features, right? You just catch the exception and then expose a feature that wraps the exception, right? So that simplifies the application because callers only need to worry about one failure path, which is having a feature that inside there is a failure, right? So that simplifies the application code. Now, going to the consumers, we're going to talk about the performance tuning for consumers. So best practices, the first thing is try to optimize the producer. So on the stream processing application, you can only be as fast as your slowest component. So if the bottleneck is the producer, don't waste time trying to optimize the consumer. You're not going to get any benefits. Focus on the producer first. And of course, the other way around. If the bottleneck is the consumer, don't try to optimize the producer. Optimize the consumer instead, right? The next one is to enable cooperative partition assignment with this configuration. So this is basically the behavior for Kafka on rebalances. So if you have used a consumer before, you probably have seen a situation where you get some logs talking about a rebalance happening. The way this works is each consumer, by default, it's part of the consumer group. And Kafka, the consumer group and the brokers, they're going to partition distribute the partitions that need to be consumed across the consumer group. So for instance, let's say you have a topic that has 5 partitions, and then you have a consumer group that has 5 consumers. What's going to happen is Kafka will split the 5 partitions and give each consumer 1 partition each, basically. So it's going to be spread even. Now, let's say one of those consumers goes down. What's going to happen is the consumer group is going to take that partition that's now unassigned and give it to another one of the consumers, right? So that's a rebalance. The thing is, under default configuration, when you get a rebalance, all the consumers on that consumer group, they have to stop consuming. They basically have to relinquish access to their partitions. That goes back into the consumer group and the brokers to distribute, and then they assign it back, and only once everyone is assigned again the partitions, they can consume the messages, right? So the problem is if you're doing a deployment, especially if you're doing something like a canary release or a blue-green deployment, or you have a consumer that's slowing down, there is a network issue between the application and Kafka, or the cluster is busy. Any of those situations, you're going to get rebalances. And if a rebalance means that all the consumers on this consumer group have to stop reading messages, then you're going to harm your throughput, right? So this cooperative partition assignment, which again is not a default configuration, you need to change. What it does is it does basically what we expected, which is if back to the example I mentioned before, if you have 5 partitions, 5 consumers, and one of them goes down, only the consumer that's going to receive the new partition, only that one will start consuming from the topic, right? So that's the behavior we kind of expected, and that's why this is it's recommended to change this, because it's going to increase the throughput for the consumers when a rebalance happens. Now, the next thing I recommend is to ignore duplicate or outdated messages. So let's say that we have a topic that has thin events, right? So the event, the message, it doesn't capture state. It just says that something has changed. So let's say we're talking about retail, right? And we get a message from the topic saying that this product ID there is an inventory change, for instance, right? So it doesn't capture what exactly has changed. So if you have a consumer that's dealing with this sort of data, right, then you don't need to process every single one of these events. You just need to process one, right, because it's a thin event, right? You can either process the first one, the last one, doesn't matter. You can ignore the other ones. Or let's say you have a message that captures the entire state, right? So again, using the retail example, this time we would have a message that says, product ID at this location, there is 10 units available, right? So if you have a topic like this, and you see a bunch of messages for the same product, for the same location, you don't need to process all of them, just process the last one, because that's the one that has the final state, right? So we have a project where we took like a sample of data from production, and we noticed that there were a lot of repetition, right? So we ignored the outdated messages. In that case, the topic was not a thin event topic, and it was a game changer, like in terms of achieving the SLA. We had a very strict SLA for this project. We see time and time again, there's a lot of repetition, and this is a simple way to filter data in memory that saves a lot of resources. So of course, we will only be able to use this if there is a lot of repetition on your use case. So you have to understand that first, but it's a simple change that's really efficient. The next suggestion is to keep micro-batching, right? So the consumer gets a batch of messages from Kafka. And to simplify things, you can process one message at a time. But if you need the performance, then keep micro-batching. So internally, if the consumer is going to call an API, do a bulk API call. If it's going to call a database, do a bulk database call, right? Then if you're doing this, you might want to take a look at changing max pool records. This limits how many messages the consumer is going to expose to your application, right? Internally, the consumer is going to get a batch. So if the batch is 10,000 messages, it will get those 10,000 messages. It will be there in memory, but it will only give it this much. So the default is 500. So out of the 10,000 messages, the consumer is only going to give to your application 500 messages, right? But if you're doing bulk calls, right, and the data is already there in memory, you might want to consider increasing this so you can do larger batches internally. Now, the problem is doing this, this micro batching, it does make the application more complex, especially when it comes to error handling. And that's what we're going to discuss next. So another story time. So this is a project where we had a consumer that we had a strict SLA, and we knew that we had to do bulk processing. But the problem is we had to call an API, but the API that we're supposed to call varies based on the message, like a message attribute. So how can we do like as many bulk calls as possible if that's going to change the order to be processed the messages? So let me give an example. Let's say we have these messages. This is what the consumer has in memory, right? We have 6 messages. We have the offsets here, so offset 0, 1, 2, and so on. And the messages have a bunch of stuff, but the only thing we care about is the country for this example, right? So the country have US, we have the UK, GBR, and we have Canada here, right? And we need to enrich the messages by calling an API. And the API we're supposed to call is based on the country, right? So for instance, for US, we need to call api.com, for UK, api.uk, and so on. So, okay, let's say we do the batching approach. We take the messages and we group them by country, right? So we have a batch of 3 messages for US, another 2 messages for UK, and a single one for Canada. Now, the problem is, let's say we do that, we go ahead, we call the API for US, it goes through, very good, right? But then when we go to call the API for UK, it fails. We do retries, but we can't retry forever. Eventually, we had to give up. Now, what are we going to do? Because we could go and say, hey, I processed the US messages correctly. So I'm going to commit the offset of the last message from US, which is offset number 4. The problem is, if you do that, you're going to tell Kafka that you consume messages 1 and 3 from UK successfully, because they are before message number 4. So this is data loss, right? It may be okay for a situation, it may not be okay. Another option is you can take the offset of the first failure, which is offset number 1, and you can commit the message immediately before that. So in this case, the message immediately before number 1 would be 0, and they would only commit this very first message, okay? Now, that also has a problem. Next time your application gets messages, these 2 are going to show up again, number 2 and number 4, because you only committed offset number 0. So in this case, depending on what your application does, you're either going to get a failure because you're processing, trying to save the same thing on the database again, or it's going to have a duplicate, it's going to introduce a duplicate on a topic. So which one you can do, it's going to depend on your situation. For this project in particular, we were okay with duplicates, so we would commit the offset number 0, and this would end up being duplicate. Now, there is another way to handle this, which is becomes a bit more complex, but it's what we're going to discuss next. It's non-blocking retries. So this is something that's available if you're using Java and Spring. Spring Kafka has this available out of the box. We haven't using any project so far because the use case we had for this, we had to do something a bit more robust. But basically, the way it works is, let's take that previous example. The messages from UK, they failed. Instead of committing the offsets, first we would take those messages and send to a secondary topic. Let's call it a retry topic. And if that works, we commit the messages. So in that example, we would consider that we recovered the message from UK because we published them to the retry topic. Then a secondary consumer, it's going to take the messages from the retry topic and process in the same way that they are supposed to be processed, right? Now, the problem you get in a situation like this is that you can have concurrent consumers and you can have lost updates, which is exactly what happened in one project. We knew that would happen, but just to explain the situation, we have the main topic and we have the main consumer, right? We need to call an API, and then after this is successful, we save to a database, right? Now, if it fails, for instance, the API call fails or the database call fails, we push the messages to the retry topic. And then a retry consumer will eventually take the messages, call the API, and save on the database, right? The problem is, let's say we're talking again about retail, and we have product ID 1, and we consume a message from the main consumer, it calls the API, and it fails. So it sends a message to the retry topic. But while the retry consumer is processing that, the main consumer gets another message from product ID 1 saying that there is, 10 inventory available. And let's say the previous one was 5, right? If the main consumer is able to save on the database first, what's going to happen is eventually the retry consumer, it's going to overwrite the more recent value with an older one. So this is the loss update problem, and exactly what we had on a project. We never got to implement this because we were aware of the situation during architecture. So we did something different to avoid loss updates. So it's the same situation. There is only a minor change that solves the loss update problem. When the main consumer, it takes the messages, it calls the API. When it's trying to save the data on the database, it's going to include the offset from the message on the original topic as a version number. So there's one extra attribute. You save the offset on the database, right? Now, let's say that the main consumer, it calls the API and it fails. Then it's going to send the message to retry topic, but it's not going to be the same message. It's also going to include the offset as a version number, right? And then the retry consumer, it would take the message from the retry topic, call the API, but there's a change here. The retry consumer, it's going to do like a conditional update. It's only going to update the version on the database if the version that it has, the data on the database, if the version it has in memory, it's higher than the version that's stored in the database, right? So this is basically compare and set operation. Now, this solves the situation that we had, and it's what we had implemented on the project. This is more of a niche situation, like you need to have consumers that have an unblocked retries, and then they save data in the database. Database needs to support conditional updates, atomic conditional updates, so either SQL or something like Cassandra and so on. But the important technique here that I think it's used for more projects, it's to use the offset as a way to order events, even outside of Kafka, right? Because from the consumer perspective, the order of messages on the main topic is the source of truth, right? If you care about the order, this is the order that you should care about, right? So even when you are outside of Kafka, you can use the offset to order events, right? You do have to be careful about one thing, which is what happens if you change the amount of partitions on this topic, for instance. If we increase the amount of partitions on the main topic, this logic will be off. Because let's say, for instance, we had product ID 1. It was assigned to partition 0, and the offset was on top 1,000. If we increase the amount of partitions, it's quite possible that now product ID 1 is going to sit on partition 5, and the offset goes back to 0, right? Let's say it's the new partition, the one we just added. And then in that case, this comparison logic we have here, it would be off, right? So what it can do is either you can, I'm going to briefly go over this because it's a very specific situation, but you can either reset manually the versions on the database, or you could also look at storing the partition on the database, right? So you're going to update if the partition is different, or if the partition is the same, you're only going to update if the version on the message is higher than the version on the database, right? For this particular project, we went with just storing the version. We haven't increased the partitions. It's not been a problem so far, but we do have the process documented in case it needs to happen in the future. Okay. So there are a bunch of other things I would like to talk about, but I don't think we're going to have time. I would also like to take some time for questions. Like I would like to, discuss a bunch of other things we use in projects. We use how to do schema evolution properly, avoid issues, how to use Kafka transactions, Kafka connectors. We have been using Kafka connectors increasingly, how to monitor them properly. But if you have a specific use case, the good news is I'm one of the backend mentors at Avenue Code. So if there's something related to Kafka we want to discuss, if you have a specific use case that you need to have an idea how to do, or even outside of Kafka, if you have you would like to discuss about databases, SQL, NoSQL, any backend stuff. So you can reach out to me. I have a couple of appointments available each week for mentoring purposes. You can schedule some time, and we can discuss whatever you want to discuss that's related to backend. If I'm busy, I'm not the only mentor at Avenue Code. There's also Thiago for backend. So you can reach out to either one of us and schedule some time to discuss anything you want to talk about backend. Okay. Any questions?